Our last one, the last way that we're going to charge an object is through polarization. With induction, this one worked only for conductors. This one's going to be only for insulators. We can do something similar with conductors, but this specific example, the specific way of charging works only for insulators because the electrons aren't free to move around as much with insulators. In insulators, what the electrons can do is they can kind of move around within the room, but they're not allowed to leave. They can spin their molecule, but they can't leave their molecule or their atom. So what we have here for polarization is we're going to have a supercharged object just like before. So let's say this time we have a supercharged like balloon or something. We have lots and lots and lots and lots of negatives on it. So here's our charged object. And we're going to bring it close to like the wall, which is an insulator. And it's neutral. It's got the same number of electrons as protons. The walls here, they're not electrically charged. We'd probably get in trouble if we electrified the walls. Kind of be more fun. So what we have are these positives and negatives, and we're going to make them kind of look like capsules, like medicine capsules. And they would be alternating, plus and minus, plus and minus, plus and minus, to kind of show that this would be a neutral wall. So for polarization, what we're going to do is kind of similar to over here. We're going to bring this charged object close to the wall. So what we're going to have is this charged object really, really, really close to the wall. And what happens when we bring it super close to the wall is that these electrons right here don't want to be near the balloon. They don't want to be near this electrically charged, negatively charged object. They're not allowed to leave, but they're kind of like going to spin around, or they're going to hold the proton in front of them and hide behind them and be like, no, I don't want to see the negatively charged object. So what we're going to have are these little capsules that we've created representing our molecules spin around the other way so that our electrons are now as far away as they can get from the balloon. So they can't leave like they could in a conductor. They can't get all the way to the end of the wall, but they can kind of throw their protons in front of them and be like, no, 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 I'm hiding behind you. Well, when you do this, you've created a surface charge. It's a surface charge because all the protons are now here. But is the object really charged? Is there an excess of protons or electrons? No. Polarization is the only way to charge an object in which you're not removing or accepting any electrons. All you're doing is rearranging the charged particles. So what we're left with is this surface charge with this positive here. This is why if you take a balloon and you rub it in your hair and you make it all electrically negative and you bring it up to the board or you bring it up to the wall, why it's going to stick. Because these negatives are now going to be attracted to these positives. And it's going to stick right there because this is an insulator. So they're not going to take the electrons away from the balloon really fast. They're going to slowly go over because they're not allowed to move inside of an insulator very quickly. So that's why the balloon will stick to the wall for a little while and then just slowly come down as soon as those electrons have been removed over. So those are our three ways to charge an object. Conduction, which works for both. Induction, which works for conductors only. And polarization, which works for insulators.